Today's episode of K2 TV is about the K2 Try Now experience. This solution aims to bring K2 into the hands of our customers as quickly and efficiently as possible while utilizing K2 technologies. The challenge we had was that potential customers want to try out K2, but they don't necessarily have the in-house infrastructure in order to set up K2, the skills to install it on the box and to start being productive. So we wanted to build an environment that had tutorials and was easily available, was online for them. The process to set their machine up obviously had to be efficient, transparent, and very flexible because it needed to cater for a variety of different situations. And we didn't want the customer to have to wait too long for a machine to be available for them. And of course, we had to integrate it into our website and our own internal infrastructure using existing skills and technologies. So the solution we came up with was to utilize on-demand computing on the cloud. And by that, I mean use the likes of Amazon, OpSource, Microsoft Azure, one of the cloud providers, to stand up a machine for the customer and then use K2 to orchestrate the workflow of actually setting that machine up. So when you create a machine on the cloud, there's a variety of steps to do that, and you need some way of running a workflow that sets that machine up in the way you need it to run. Finally, we hooked it into the front end using .NET technology, so ASP.NET and all the rest of the suite of products in Microsoft.NET, and so it's fully integrated into our K2.com website. And on the back end of particular importance is the way we got the workflow to speak to Amazon itself is via the Amazon SDK. The Amazon SDK has a programmatic way of interfacing with their own REST API, but we needed K2 to speak to that service layer, and we did that using a service object. To do that, we built a virtual environment for each customer in the cloud, using Amazon as a backend provider and using our own tools and technologies on our front end in order to orchestrate the experience. So the first thing we did in Visual Studio was to build a couple of service objects that K2 would use to drive the whole process. So a service object is a way of interfacing K2 with your existing business environment. In this case, we treat Amazon as a line of business entity or data source, and we build a service object around it that allows us to very easily interact with Amazon from a K2 workflow. Here is one of the methods, and it's the deploy method. What we do on the deploy method, we've got various parameters that it accepts. Now, these parameters will be exposed to your K2 workflow. So when you call this method from K2, you're going to have to pass in things like the image ID and network ID. I'll explain what those are later. But the important thing about those is that we've decorated them with attributes. So what's nice about this is that I'm writing it as a normal C# method. I'm a programmer, I'm using my existing skills. I don't have to learn something new. And then to expose it to the smart object world, I simply give it these attributes that tell smart objects how to consume this object. So in this case, what I'm telling it is there's a parameter called network ID. I'm telling it here is what I want you to use for its display name, a network underscore ID in this case. I chose that. I could choose anything I like. It's of type string or text. I can add descriptions and all sorts of other things here. I've kept it simple for this demonstration. So I've got my various parameters that have come in now. And then inside my code, once again, this is just a whole lot of checking to make sure things are robust. I'm getting values that make sense. And down here is where I'm doing the real work, where I'm going and I'm taking the image that the user specified. So when you create an image on the cloud, you can specify which image you want to use to do it. You want to use a Windows image or a Linux image or a custom image you've built. And each image has an ID that you pass in. So in this case, we're going and we're finding that image, making sure it actually exists. When you deploy a machine on Amazon, you also get to choose where it lives. It's called a security group on Amazon. I've renamed it to a network, but the point is the same. It's a virtual LAN that you wanted to put this machine on. Do you want this machine to be small, medium, or large? And so on and so on. There's various attributes you can give this thing. And finally, we call into that SDK wrapper we built earlier using these parameters. So it's pretty simple. That's all there is to it. I wait a little while for the machine to get created, and then I go and I add some attributes. I decorate the actual instance with some a description and so on, so I can find it easily in the catalog. And that's pretty much all there is to it. I'm also able to do things like start the image and stop the image using exactly the same mechanisms. If we go have a look at some of these other methods, here's the shutdown method. And here what we're doing is we just check that the instance ID is valid. That's actually a value that makes sense. And then we call into that wrapper and we ask it to shut the instance down. There's some other methods that we add that give us a lot more value. So the SDK by itself gives you a lot of functionality, the Amazon SDK, but there's some stuff it doesn't do. For instance, there's no way in that SDK to ping the machine and make sure it's actually alive. So if you want to set up a machine and then 2 months later, start pinging it to say, have you started, are you actually up and running yet? There's no way to do that in the SDK. So we built using C# a little ping method. The ping method sends a value to the machine and pings and just makes sure whether it succeeds or not. Now, what was interesting when we used this, we used the ping method to be able to tell our process whether our workflow process, whether the machine had passed the first step, whether it was up and running, and we could proceed to the next step. What we found is that when Windows starts responding to a ping, it doesn't actually mean it's alive and ready to actually start doing things. You cannot access it via remote desktop for quite a while. So the next thing we built was a method called probe. And what probe does is to go and try and attach to that instance using sockets, using a TCP socket on the RDP port. Now, if that succeeds, then we know definitely this machine's ready to roll because we can actually connect to it via remote desktop. Now, the details of this code is not important. What's important here is that we've been able to build some pretty advanced functionality using Windows sockets and all sorts of things and expose them as simple to use interfaces in smart objects. So once we've built our smart object, we've got objects here to manage images, to manage the actual instances themselves, start them up, shut them down, and to manage networks. Once those are all in place, we simply take these things, we compile them, and we deploy them along with our K2 solution. So here we are in the Amazon console. The EC2 console is a place where I can manually create machines, start, stop machines, drop them. Very easy to do, but obviously not something that I can automate. I need to use the Amazon SDK in order to automate it. But this will give me make it easier for you to understand what's going on with our smart object. So you can see here, I've clicked on instances. You can see we've only got 4 running instances right now. I can have a look at the AMIs and see, and AMIs are all the images that we have up there. So we've got a whole lot of different images of things that people might want to try out. Some of them are just different versions, like a V1 and a V2. Amazon identifies everything they have with these abstract or identifiers that are just a bunch of letters in a string. And so when we built the smart object, the way that you need to call into their APIs is that you need to pass these things around. So you'll see later on when we use a smart object, we pass these identifiers in as the name of the images and so on that we want to create. That being said, Amazon does allow you to decorate all your objects with what they call tags, which is just metadata that gives it friendlier names and so on. But at the end of the day, Amazon only cares about these identifiers, both on the machines, on the instances, on the networks. Everything you do in Amazon has these identifiers. So what we're going to do is we're going to go and create a new machine based on this image. This image has got some of our latest software running on it. I went and copied and pasted that value into the smart object tester. I'm going to show you what that does. So let's go back to the instances. You can see there's 4 of those running. I'm going to step into the smart object tester. Now the smart object tester is not something you'd ever use in your production code. This is simply a debug environment for you to test that your smart object is working properly. So it also makes it very easy to demonstrate what's going on when you build a smart object, when you want to show it to people. So here I've started up the smart object tester. I've connected to my Amazon instance. You can see it here, my Amazon smart object. There's a whole bunch of methods I can now call on it. Now this box got populated automatically. If you remember in the development environment, what I did is I decorated all the methods and parameters with C# attributes. By doing that, K2 was able to reflect on that assembly that I built and derive all these properties automatically. So I didn't have to do anything to populate this environment here, this UI, it's all done automatically. So I'm going to call the deploy method. When I chose deploy, these parameters all popped up, and I filled them in with those identifiers. So that happens to be that image I showed you earlier, that one with our latest software. There's the network I want to put it on. It's an identifier for that. The kind of machine I want to use, I want to start up a large machine. I want to start it up in the US East. Amazon has various data centers, and we support our object support starting up machines in all of them, all the way in Asia and Europe and all over the world. And finally, I can give the machine a tag to give it a friendly name, the metadata decoration I spoke about earlier. I'm going to hit execute. And what's going to happen when I hit execute? My C# smart object is going to be called. That object is going to go through all the parameters and check that they're all, that they all exist and they're valid. It's going to then call into the Amazon SDK, and the Amazon SDK is going to make a REST call over the internet to Amazon, and it's going to start up a machine for us. Now, because it's going over the internet, everything's running asynchronously. In other words, you cannot rely on the time it's going to take, because it's kind of a fire and forget call. So you call create machine, and it returns pretty soon after making the call, and then what you have to do is keep checking the machine and seeing if it actually is ready to run yet. So while that's ticking over, we'll spin for a couple of seconds. There we go, it's done. It's come back and it's given us the instance ID of the machine that it's created. So here we are back in the Amazon console. As you can see, we've got the machine ready and waiting for us. In this case, we had to wait about 4 minutes in total for the APIs to fire off the request and then for Amazon to spin up the machine, and it's in a running state. So what we can do now is, because we wait a little bit of time, we're actually able to connect to it. We can do this, we're doing this in the Amazon console just to prove that it's there and that it works. But in our real solution, you'll see how we do this differently. So it's very easy for me to just use remote desktop to connect into this machine. And we're in. And if you imagine I'm a user now, I could go and I could start using the software. However, that's obviously not an end-to-end experience that's very useful, because our end users are not going to be hitting the Amazon console. They're not going to be doing stuff directly there. So what do we do instead? Well, we continue using the K2 smart objects. The next smart object we use is a smart object that allows me to connect to the instance. When I enter in an instance ID and a username, a couple of other parameters, what it will do for me is to build me a remote desktop connection file. It will bring that locally to me, and I can use that to connect to the actual environment. So here's how we hook up the smart object method into our workflow. What I've done is I've dropped a smart object event into one of the workflow steps. I've opened up the property page of that, and that gives me a wizard that I can walk through. The wizard gives me a browser that lets me enumerate the smart objects as on my server. Obviously, the smart object we built earlier is now a reusable component that I can use from any of my workflows. So I needn't even use it just for the try now experience. I can use the same smart object in any other workflow my business requires. In this case, I'm going to grab the instance smart object. There's a whole lot of methods on this smart object that I can select from. In this case, I'm going to choose the deploy method. I simply drag it on. You can see how easy it is to utilize the environment. Hit next. It goes and it automatically figures out what the parameters are for this call. And as part of this workflow process, I have defined some parameters that form the context of this particular operation. So I can go and have a look at those parameters. In this case, I can go and say, I want to take the name of this image, and I'm going to use it as pass in the parameter. I'm going to tell it which network I want to put this image on, pass that in, and so on and so on. I can even build into expressions as parameters. So here we have, we've passed in the input parameters. We're now going to, out of that, get the parameter that establishes the ID of the instance that Amazon created for us. And given all that, I can hit finish, And now what happens is my process is calling into that smart object, creating the instance for me, and passing back the key of the instance that Amazon created for us. So here we are on the K2 site. I've gone to the URL that allows me to as a customer, test out the K2 Black Pearl technologies. I filled in my user information. I hit the big button saying request trial access. I'm submitting the form. What it's going to do now is this web page is going to call a workflow that in turn is going to go through a whole orchestration of setting out emails, setting out authorizations and approvals. It's going to call into Amazon. It's going to create the machine. It's going to, when the machine started up, it's going to keep checking it, it's going to ping it, it's going to try and probe it and access it via the RDP port, as I spoke about earlier. And finally, when everything's ready, it's going to send an email to the user with a URL and say, hey, your machine's ready. If we have a look at the Amazon console, we can see that here is the machine that I have just started up. And if we have a look at the tags, you can see that we decorate this instance with some metadata that just tells us who owns this machine. That's more for debugging and stuff. Of course, we keep track of that in our CRM system on the back end. We keep track of which customer has which machine and how often they've used it and things like that. While we're waiting for the machine to start up, let's have a look at the workflow that K2 runs in the background that starts up the machine and gets all the various pieces orchestrating and moving together. So at the beginning, the first thing that happens is, depending on the country that this thing's running in, the trial either needs to be approved or not. So that's what this little step does. It finds out if things need to be approved. It fixes up various customized URLs and so on, and sets up some metadata that depend on the specific customer. It sets up some tracking numbers so that we can associate machines to customers. It sends the email to the customer to say, hey, thanks for registering, and we're busy setting up your machine. It also sends the request to the approver, if necessary, to get their approval, start off their approval process. If there was an approval, if no approval was required, straight away it goes and starts deploying the machine. It calls the create instance API, smart object method that I showed earlier. It then goes in a loop, as you can see here, checking if we're able to RDP into that machine. It pings it and tries to probe its RDP port until it can get an answer. Once that's ready, it populates various fields, sets various statuses, etc. in our tracking database. It sends the user a notification, which I'll show you just now. And finally, we're done, and the user can start using it. So the process is just completed, and I've received an email telling me where I can access my machine, as well as my username and password and the expiry date. If I hit on that URL, I can go to the control panel, and here I can control my machine and do a whole lot of stuff with it. For instance, I can extend my trial right here, I can cancel my trial and kill the machine straight away. I can connect to it, I can shut it down. So if I shut it down, there'll be a start button that comes here in its place. So if I hit the connect menu option, it'll give me that little RDP file I spoke about earlier. I can enter my credentials, and I'll log straight onto that machine that's hosted on Amazon. What's really cool about this is we also use the Amazon infrastructure to set up a remote desktop gateway, meaning that you can access the whole remote desktop environment over port 80. So if you have a corporate firewall, you can still use remote desktop because it will tunnel over port 80, which is very cool. So here we have the environment. I can go and read about K2. I can run through the tutorials, and it's very easy for me to use. So in summary, we've seen a very powerful environment that we've built using K2, and in this case, our cloud provider being Amazon, to build customer evaluations up on the cloud. K2 allows you to connect to the cloud provider, stand up machines, drop them down again, and to orchestrate the whole process with approvals and emails and a good user interaction. Very easy to do, and very little development effort to achieve huge business value.